Hello, welcome to my YouTube channel. Today we are going to look at uniformly distributed load. This is a topic that every mechanical and civil engineer is supposed to familiarize himself or herself with. So to start off, I have a sketch that I'm going to use to illustrate how we are going to get the shear force and the bending moment diagram. So at the top here, I have some arrows that are drawn pointing downwards on my beam. This is the symbol for UDL, uniformly distributed load. It has a value of 2 kilonewtons per meter. Also, on my beam, we have a force of 6 kilonewtons that is acting on it. Then the distances are given. So I'm going to start by drawing the free body diagram, the FBD. It is here below. This is end A and end B. End A is placed on top of rollers, end B is fixed. So for the two, I shall have reaction force RA and RB. Also, the force of 6 kilonewtons that is acting. Now, you can notice that I have an arrow with a dotted line. That is where I'm going to input the value of the UDL. So how do we get the UDL? Now, the UDL is acting entirely through the whole beam, across the whole of it. And its value is 2 kilonewtons per meter. So how do we get the value of UDL? We are going to multiply the 2 kilonewtons times the entire length of the beam. 2 plus 1, 3. So 2 multiplied by the whole length, that is going to be 6. So at the top here, 6 kilonewtons. That is the value of my UDL. So with that, I'm now going to solve the question. So first, upward forces are equal to downward forces. The forces acting upward, RA and RB. So the sum of RA plus RB. Forces that are acting downwards, 6 kilonewtons and 6 kilonewtons. 6 plus 6, 12 kilonewtons. Secondly, I'm going to get moment. Now, the sum of moment about a point A is equal to 0. This is my point A. So, the 6 kilonewtons and the other 6 kilonewtons are acting in that direction, clockwise, the clockwise direction, while the reaction force RB is acting in the opposite direction, anti-clockwise. Clockwise moment is equal to anti-clockwise moment. Therefore, 6 times, now another point to note, the UDL is going to act at the center of the beam. Therefore, 2 plus 1 is going to give me 3. So, the half of 3 is 1.5 meters. So, the UDL is going to act at the center of the beam. Therefore, 6 multiplied by 1.5 plus 6 multiplied by that distance of 2 for the clockwise moment. For the anti-clockwise moment, RB times the entire length, that is going to be 3. RB times 3. So 6 times 1.5 is going to give me 9. 9 plus 6 times 2, 12. RB times 3, 21 divided by 3, 7. RB is going to be 7. Then, back at this point, the sum of RA and RB is 12. That means RA is going to have a value of 5. Therefore, the reaction force RB, 7 kilonewtons, and the reaction force RA, 5 kilonewtons. So up to that point, we have done quite well. So secondly, we are going to divide this beam into sections. From this point to this point is going to be my first section. The second section will be from the force that is acting on it to the other end. 2 sections. So allow me to rub. Okay. So to start off, I'm going to consider a section X whereby it is going to be less than this distance of 2 where the force is acting, and greater than 0, the starting point of my beam. So I'm going to draw it to have a better understanding. Reaction force RA, a point Q inside it. This is the whole length we're talking about. X. At this end is where we are going to have my moment. I will name it M of X. And at that end is where I shall have my shear force SX. Now, another thing to note, the UDL is still acting at this point, and it is going to act at the center of the beam. Now, it has a value of 2 kilonewtons and the whole length is x. Therefore, it will be 2x kilonewtons. So with that, we can solve it. Upward forces equals downward forces. So RA is acting upwards. Downward forces, I have 2x plus sx. 2x plus s of x. Make sx the subject. Sx equals to RA, take it to the other side, minus 2x. The value of RA was 5 kilonewtons. Sx equals 5 minus 2x. Now, the limits of our point x is 2 and 0. Our section is. So, at x equals 0, what is going to be Sx? And at x equals 2, what will be the value of Sx? At 0, we shall have 5. At a point 2, we shall have 1. So we have the value of my Sx. Secondly, we are going to take moment about the point Q. So the sum of moments at a point Q is equal to 0. So RA is acting in that direction, 2x that direction, mx also in that direction. So that means RA times the entire length of x multiplied by x is equal to 2x. 2x is acting, this is the UDL, and it is acting at the center of the beam. Therefore, it will be 2x times a half of x. Please note that. Plus the moment mx is acting also in that direction, m of x. So RA was 5. 5x equals x squared, 2 and 2, plus m of x. Make mx the subject. Mx will be given by 5x minus x squared. Then our limits 2 and 0. At x is equals to 0, what is the value of m of x? At x is equals to 2, what is the value of mx? At 0, 0 and 0, I shall have 0. At the point 2, 5 times 2, 10 minus 2 squared, that is 4. 10 minus 4 is going to give me 6. And with that, I have the value of the shear force and also the value of the moment M. So I want you to note these values somewhere. We are going to use them to plot our diagrams. Alright. So secondly, we will consider the other section. We shall now look at the other section. So the other section will be whereby x is less than the whole length 3 but greater than this section, so it is greater than 2. Alright, then we draw it. So when drawing for this section, we always start from the end. Always start from this end. Our reaction force RA, a force of 6 kilonewtons. The entire length is x. I have a point Q. Moment mx. Shear force S of x. Then for my UDL, it has a value of 2 kilonewtons per meter. The entire length is x, therefore 2x. So another thing you're going to notice that the value for UDL is going to be similar to the previous section. So with that, upward forces equals downward forces. Upward forces, we have RA. So RA equals to downward forces 2x, 6, and the shear force SX. 2x plus 6 plus SX. Alright. RA was 5. Therefore, 5 equals 2x plus 6 plus SX. Make SX the subject of the formula. 5 minus 6, negative 1, negative 2x. So input our limits, 3 and 2. At x is equals to 3, what will be the value of Sx? And at x equals to 2, what will be the value of S of x? So negative 1 subtract negative 2 into bracket 3, negative 7, then negative 1, negative 2 into bracket 2, negative 5. Alright, so I have the two values for the shear force. So we look at moments. Now the sum of moments at a point Q. Sum of moments at a point Q is equal 0. So we start evaluating RA in that direction, clockwise, 2 kilonewton, 6 kilonewton, and mx are all heading in the anti-clockwise direction. So RA times the whole length of x equals 2x. It is acting at the center of the beam. Allow me to write it this way for you to remember. So it will be 2x times a half of the length, a half of x, plus 6 multiplied by, we are interested in this length, and from this point to this point had a length of 2. So this point will be the whole length x subtract 2. X minus 2 plus mx. RA was 5. Therefore, 5x equals x squared plus 6x minus 12 plus mx. Make mx the subject of the formula. Mx is going to be given by 5x minus 6x negative x squared plus 12. So with that, we also evaluate for that part the limits 3 and 2 at x is equals to 3, at x is equals to 2. What is the value of mx? So at 3, negative 3 squared plus 12, negative 3 3 squared plus 12, 0. Then at my point 2, negative 2 squared plus 12, and that is going to give me 6. So now I have the two values of my shear force and also the values of my moment. So I want to write them here so that I can be able to plot with ease. So for the first section, that was x being less than 2, greater than 0. Allow me to just read them. At x equals to 0 and at x equals to 2, sx, we got 5 and 1, then 0 for mx and also mx, 0 and 6. Secondly, for my second section, x less than 3, greater than 2, x equals to 3, x equals to 2, sx. So at a point 3, sx was negative 7, point 2, negative 5, mx, at a point 3, 0, at a point 2, 6. All right. So with that, now we are going to evaluate. So for me to be able to draw with ease, I'm going to draw this on this other section. There is a reason as to why I'm doing so. Then the fixed end is a distance of 2 meters, 1 meter, then a force of 6 kilonewtons, and another force for the UDL, 6 kilonewtons. So I'll start by plotting the shear force. Start at the margin. So for shear force, the greatest value I have is a positive 5 and a negative 7. So I can start from 5 to 4, 3, 2, 1, 0, negative 1, 2, 3, 4, 5, 6, 7. Let me just write it at the top here for you to be able to see. 2, 3, 4, 5, 6, 7. Of course, these are negatives. Then the margin, my axis. So with that, so we start At the point x is equals to 0, Sx is 5. That is the point. At the point x is equals to 2, S of x is 1. So I'm just going to drop down this line. So and this is going to be my point 2. At point 2, Sx has a value of 1. Then in the other one, at x is equals to 2, Sx a negative 5. That point. Then at the point 3, Sx negative 7. So this is my point 3. And it has a value of negative 7. So join the lines, the dots. That, then a straight line, then to that point, then join that. You can shade the wanted region. And yeah, that is it. It is as simple as that. So below this diagram, I had limited space. So below it, we are going to plot for moment. This is for shear force and value of n newtons, a length in meters. So for moment, just below this one, when plotting for moment, so similar to the other one, start from the axis. Then the greatest value I have is a 6 and a 6. So 6, 5, 4, 3, 2, 1, 0. Probably a negative 1. Now at x is equals to 0, mx is 0. At x is equals to 2, mx is 6. So I'm just going to drop that line. The value of mx 6. Then at x is equals to 2, mx is 6. This is where I had 2. So still the same point. At x is equals to 3, mx 0. So at the end is my point 3, which has a value of 0. Then you just join it. Make sure you have a smooth curve. Make sure your curve is smooth. Then you can shade the wanted region. And yeah, that is it. So probably label the axis, moment, Newton meter, and then a length in meters. So that is it, the shear force and the bending moment diagram. Thank you for watching. If you have any question, just write them down below in the comment section. Thank you.